All right, today we are diving into 8E, which is inverse trig ratios. We've already talked about trig ratios, and both trig ratios and their inverses can be used as indirect measurement. In other words, we're trying to find measures of certain things without getting out the tape measure or the ruler or the protractor, but just based on certain ratios that we know of or certain angles that we know of, we can actually find measurements. Okay, so in this lesson, we're trying to, again, use right triangles, but instead of using sine, cosine, and tangent, we're going to use the inverse of sine and cosine and tangent. But let's do a little bit of a review first. Okay, so if I've got problems like this that I'm looking to solve for x, first I want to identify the certain sides of that triangle. And so let's look at the one on the left. This is the hypotenuse over there, based off of this 30-degree angle as kind of our reference angle that we've been given. That would be the hypotenuse, and the 12 down here would be the adjacent side. Okay, so now when I set up some type of equation, I want to think in terms of SO, CA, TOA, and given the fact that I've got the H hypotenuse and the A adjacent, looks like to me like I'm going to use this one, which is cosine. Cosine has the adjacent over the hypotenuse. And so I'm going to say that the cosine of this 30-degree reference angle has to be the adjacent over the hypotenuse. Well, the adjacent was 12 and the hypotenuse was x. So that's the initial equation that I should get here. And now I'm going to try to solve for x. I want to do that by multiplying both sides by x. The reason I do that is to get it out of the denominator here. And now I've got x times the cosine of 30 equals 12. I'm going to take that and divide away the cosine of 30 on both sides. If I do that, I'm just left with x, and x equals 12 divided by the cosine of 30 degrees. And here's where you have to make use of the calculator. I don't know what the cosine of 30 degrees is off the top of my head necessarily, but if I take 12 and divide by the cosine of 30 degrees, I get a value that is approximately 13.9. Now, if you get something different and you did 12 divided by the cosine of 30, you might have your calculator in the wrong mode. You might have it in radian mode instead of degree mode. I'll talk about that a little bit later in this video as well. Let's take a look on the left hand or on the right hand side. Again, you want to identify which sides you have. Here's my 60-degree reference angle. Based on that, x would be the opposite side, and 33 would be the adjacent side. So again, going back to SO, CA, TOA, which one of those has the A for adjacent and the O for opposite? That looks like tangent, right? Tangent is the opposite over adjacent. So in this case, I'm going to use the tangent ratio to help me solve for this. So I will say that the tangent of that 60-degree angle is going to be opposite over adjacent, where opposite in this case is x, and the adjacent is 33. Oops, changing colors on me. Okay, so now I'm solving for x again. I want to multiply both sides by 33. That way it's out of the denominator. 33 times the tangent of 60 degrees equals x. And again, just plug that into your calculator. 33 times the tangent of 60 should give you approximately 57.2. Oops, not degrees, sorry. 57.2 is our distance of that side that we're missing. Okay, so that's a review of some of the trig ratios that we've already used. Let's get into what the inverse trig ratios are. And in order to understand inverse trig ratios, you have to understand the concept of these reverse operations. And this is something that you have been doing ever since you were in, the lower grades in grade school. At the time, you probably called them fact families. You might have seen something like this, where you had a triangle, and you had 5, and you had 7, and you had 12, and your teacher told you, make an addition problem out of that. And you said, well, I can do that. The two small ones have to equal the large one. Make another addition problem. Well, I guess I could just flip those around like this, and it's still 12. And both of those are true. And then your teacher said, make a subtraction problem. And so you took the large number and subtracted away one of the small numbers, and you could do it one more time with something like this. So you had a group of addition problems here and a group of subtraction problems, and those were really an example of reverse operations. They're using the same numbers, but they go together in kind of an opposite way. So let's take a look at some more examples kind of like that. For example, since we know that 9 times 13 is 117, then without plugging this into a calculator, 117 divided by 13 must bring you back down to that 9. Since 96 divided by 12 is 8, then 8 times 12 must be 96, because those are reverse operations. So there's an example of reverse operations in multiplication and division. We can do the same thing with square roots and squares. Since the square root of 25 is 5, then that means if I took 5 and squared it, that must be 25. Or since square root of 81 is 9, then that means 9 squared must be 81. Okay, again, reverse operations, same numbers, but kind of used backwards from one to the next. Down at the bottom, since 6 squared is 36, then the square root of 36 must be 6, and then the last one, 12 squared gives you 144, so the square root of 144 must give you 12. Okay, I'm hoping that was a fairly basic review, but it's something that you have to understand if we're going to get into these inverse trig ratios. They're the reverse operations of trig ratios that we've already done. Here is the main concept with this. We said that we were finding the ratios within right triangles of certain angles. So one of the things we might have found was something like the sine of 30 degrees. Okay, so the opposite over hypotenuse, and that gave you a value of 1/2. That was the ratio. Here's where this whole idea of reverse operations comes in. Now we look to do that in an opposite way, in a reverse way. So here we're saying if I know that the inverse sine gives me a value of 1/2, then the angle that I'm talking about must be a 30-degree angle. Okay, same kind of concepts that we were doing back here, but now we're doing them in maybe a new way that you haven't seen before. Let me do one more. Since the cosine of 45 degrees gets me a value of square root of 2 over 2, then the inverse cosine of square root of 2 over 2 must give me an angle of 45 degrees. That's how this works. Okay, a big concept to just keep in mind as we work through this. If you find the sine or the cosine or the tangent, those are values. They are specific ratios that we are finding. Okay, when we look at the inverse sine or the inverse cosine or the inverse tangent, what we're looking for is an angle. And you can see that up above too. The sine of some angle gives you a value. The cosine of some angle gives you a value. However, the inverse sine gives you an angle. The inverse cosine gives you an angle. The same could be said of tangent and inverse tangent.
Students, for the next unit, Triangle Toolkit, it is important that you're able to get your calculator set up properly. Smaller calculators are in what's called degree mode automatically, but the larger calculators, TI-83 and 84, graphing calculators, you have to place them in degree mode. To get these in degree mode, first you turn it on, and you'll see this flashing. Then you touch the word mode, and you'll see the word normal flashing. You go down, down, over until you see the word degree flashing, and then you hit enter. Then you hit clear. You know you're correct when you do something like this. Try this. Try sine 45 degrees equals, and you should be getting that 0.7071. Another one, you should try cosine 45 degrees, and you should get the exact same thing. The last one, tangent 45 degrees, you should be getting 1. So use sine, cosine, and tangent of 45, double check your numbers. Your numbers should match mine, and you're in the correct mode.